So a slightly different question this time, question 58. Lots of factorials going on and some factorial algebra, sometimes called combinatorics, a branch of mathematics. Anyway, pay attention, this is a bit tricky, this one. The first part of the question asks us to confirm that 7c2 is 21. So this involves putting 7 for n and 2 for r. So when I do that, I get 7 factorial over 2 factorial times 5 factorial. 7 factorial is on the numerator there. This is 2 factorial, and that's 5 factorial. I'm not doing any multiplying before I do some cancelling, so I cancel out as much as I can. That goes into 6 3 times, so I'm left with 3 7s, which is 21. Similarly, for 7c3, I've got 7 factorial over 3 factorial, which is 3 times 2, times 4 factorial, doing a lot of cancelling down. 3 2s are 6, 7 times 5 is what we're left with, which is 35. Okay, so there's the numerical parts of the question. Now we've got to find an expression for nc2 plus nc3. So the first step is really very similar in the sense that I'm just substituting n and 2 and n and 3 into this expression. And that gives me this rather frightening looking pair of fractions. And what I want to do initially is to add them together. So that involves making the denominators the same. So on this side, I've got 2. Here I've got 3 times 2. So what I need to do is multiply the top and bottom of this fraction by 3. Here I've got n minus 2 factorial, and here I've got n minus 3 factorial. So I have to multiply this one by n minus 2 over n minus 2 in order for the denominators to be the same as the other one. This is what it looks like when it's smartened up. So now the denominator here is 6 times n minus 2 factorial, and this denominator is 6 times n minus 2 factorial. When I look at the numerators, here I've got 3n factorial. Here, when I multiply this, I've got n factorial times n, and then I've got n factorial times minus 2. So I can now add these two fractions together. I've got 3n factorial here, n times n factorial there, and minus 2 times n factorial there. And so now what I can do is I've got 3n factorial here minus 2n factorial, so that leaves me with just one lot of n factorial, and then I've got the term in the middle, n times n factorial. So that's what the fraction is starting to look like now. It's looking a lot less scary than it was before, but I'm still not quite there because I've got a term here which has got n factorial, one lot of n factorial there, and then I've got n lots of n factorial there. So I can factorize out the n factorial. And when I do that, the factor that's remaining is 1 plus n. And n factorial times 1 plus n is actually n plus 1 factorial. So there we are, that's the final answer in the form that was required, a factorial over b times c factorial, and that's the answer that would be required to get all of the marks in a question like this. It's not worth, it is worth just confirming I've done here what the values of a, b and c are, though often they're not strictly necessary in order to get the marks as long as they've been shown in the final answer. So a bit tricky there. If you need to practice some more factorial algebra, then that wouldn't be a bad thing. If you got the right answer, got the same answer as me, then well done.